diode, and the symbol is like a triangle with one vertical line here. So this is your PN, or this is your anode, cathode. Okay, cathode is denoted as K, anode is denoted as A, or I can say this is positive, this is negative. Any of the combination you can use, positive, negative, PN, anode, cathode, to represent this one. So this is the symbol where the direction of current is always P to N. This is the current direction. Or I can say the conventional current direction in PN junction diode is from P to N, or positive to negative, or anode to cathode. So this is the same thing which is in opposite direction, like this is N, this is P, this is cathode, this is anode, and conventional current is from P to N. So even if you reverse the diode, the current will always flow from P to N. So that's why this thing are shown. So this is the construction or structural view. This is the symbol, and what are the notation we use, that is written here. Is it understood to everyone?
Yes, sir.
Okay. Now we'll see the operation. So operation means what? Basically, if you take any electronic component, the operation means how it operate. That means when we give voltage, what are the type of current, or whether current is flowing or not, whether the current direction is from one direction or two direction. So that thing are actually operation, means how we will vary give the voltage, and that depend on this voltage, applied voltage, how current will vary, that gives you operation. So this operation actually gives the characteristic of VI, or current voltage relationship. So we'll see one by one what are the different techniques or operation we can perform using diode. So there are three possible operation using this diode when we apply voltage. First one is no bias. That means if we not apply any voltage, then that is called as no bias condition. To represent that, I can make the diode symbol, and here you see this is P and this is N type. I'm not connecting anything. That means voltage is 0. Next condition is forward bias. That means I'll take a diode P and N, then the P type material is connected to higher potential compared to lower potential. This is plus, this is minus, so V greater than 0, maybe 5 volt, 10 volt, 2 volt, 1 volt, any positive value. Then I can say this is your forward bias condition. Now the last one, that is reverse bias condition. If I take the diode and this P side will be connected, someone has unmuted, please mute yourself. P side will be connected to less potential compared to N side. I think this is positive, this is negative, so V less than 0. And this is called as reverse bias. 755, mute yourself. Is it understood?
Yes, sir.
Now generally the forward bias and reverse bias, if you see somewhere, or if you search somewhere, maybe generally they will tell the PN junction diode, when the P side will be connected to positive and N side is connected to negative, then that is called as forward bias. And if P side is connected to negative and N side is connected to positive, that is reverse bias. That is not fully true, or I can say that is not perfect. Okay, so whenever you tell that P side will be connected to higher potential compared to N side, because let me take an example here. Voltage means what? 5 volt, right? Potential difference between 2 points. So if I draw like this is positive, this is negative, and I'll say this is 5 and this is 0. Then the potential difference between these 2 points is your 5 volt. Yes or no?
Yes, sir.
Now same thing I can represent like this also. Suppose this is my 7 volt, this is your 2 volt. And what is the potential difference between these 2 points?
5 volt.
5 volt.
This is also 5 volt. But both are not positive, negative. This is positive, this is negative, or 0. Here both are positive. So when I connect the diode like this, in this condition, in the first case, I can say P is connected to positive, N is connected to negative. But in the second case, it is not true. P is connected to positive, N is also connected to positive. This is also plus 2 means positive, here also positive. So what more appropriate? P side will be at higher potential compared to N side. Then my diode is forward biased. Are you clear?
Yes, sir.
Sir, can
Yes.
you again?
Suppose 2 volt means what? What do you understand by voltage between 2 points? Who asked me? Suppose I am saying between 2 terminal, I am giving 2 volt. That means what? The potential difference between 2 points is 2 volt. Not like that, one is positive, one is negative. I cannot say one is positive, one is negative always. Even that is true. Suppose I'll say this is my 3 volt, this is or 2 volt, 0 volt. I can write 5 volt, 2 volt. I can write 7, 5. I can write 1 minus 1 volt, or anything which can clarify the potential difference between these 2 points is 2 volt. If you see, this is 2 volt, here also 2 volt, here also 2 volt, here also 2 volt. Yes or no? Who has asked me?
Yes, sir. Yes, sir.
So if you consider the first case, then I can say this is positive, this is negative. For second case, also I can say this is positive, this is neutral, or common terminal, that is negative. Here I can say this is positive, this is positive, this is positive, this is positive. Then when I say to get 2 volt potential difference, always I take plus minus. That is not always true. It may be both are positive also, that is okay. But why I am telling these things? In transistor, you observe at that point, when we bias the voltage or the terminal between emitter collector or emitter base or base collector, then we'll assume the potential difference between 2 terminal is only with respect to another one, not like absolute value or compared to 0. Positive negative means you are comparing with 0 volt. With respect to 0 it is positive, with respect to it is negative. But here we are comparing this potential and this potential. With respect to one, another one is positive or negative. Clear? So whenever you say the diode is forward biased, means P type should be connected to higher potential, N side should be connected to lower potential. Then the diode is forward biased. Is it clear?
Yes, sir.
Yes, sir.
Okay. So when I have not connected any voltage, then that is no bias condition. When I'll connect positive voltage, then forward biased. When I connect negative potential, then that is reverse biased. Then one by one we'll understand. Now before going to that, let us first understand. Already you have discussed these things. You have to tell me here. Let us take this is P type and this is N type. Tell me what are the carrier or charges I'll find in P type and N type.
P type holes.
What?
Sir, holes.
Holes means what? What are the type of carrier you have to tell? Na holes as majority carrier.
Majority.
Holes as majority carrier. Like that you have to tell. This is the holes and this is the majority carrier. But the minority carrier?
Electrons.
Electrons are minority carrier. What type of ions I'll find?
Positive.
Positive. P type means what type of donor we are at, donor or acceptor I am adding? What type of impurity I am adding?
Traveling.
Acceptor or donor?
Acceptor.
Acceptor. So when it accept one electron, it become positive ion or negative ion?
Positive.
Negative. Negative.
After explaining everything, you are saying positive. The number of proton and number of electrons are same. If one electron is added, then obviously the number of electron will be more compared to number of proton. Then atom will become negative or positive.
Negative.
Then who are saying positive? So I'll get negative ion. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Let me take another hole. It is balanced. Okay. Similarly, tell me in the N type, electrons are majority carrier, holes are minority carrier, and what type of ion I'll find? Positive. So now, if you understand this concept, then we come to diode. So if you see this left side diagram, what are present here? You see this one is P type or N type, you tell me. First one is
P.
P type, second one is N type. And here electrons are not shown as minority carrier. Let me show electrons as these dots. Okay, so electrons are like this. Right hand side, or we'll take electron as minus, so it will be uniform throughout the discussion. Okay, it is not shown here, so let me show some electron here. So this is your P type, this is your N type. So in N type, the holes are present, so these are the holes. Okay, now you understand what is P type, what is N type, and they are separated. That means they are not joined yet. Both are different material and they are at a distance between them. Now when I try to bring this P type and N type close together and joined, then I'll get PN junction. You see here, this is the junction, this is P type, this is the N type. Now in this condition, what happens? In this P area, what is more? What type of carrier is more?
Holes are more.
Holes are more. P type, holes are more. And N side,
Electrons.
Electrons are more.
Forget about the ions, because ion cannot move inside the material. We are not discussing about the ions. We will only discuss about electron and hole. So let me show some positive charge also here. Now, last class we have discussed about the diffusion current. So why diffusion occurs? Or what is diffusion current? Last class we have studied diffusion current, drift current.
Yes,
What
sir.
is diffusion current? What is diffusion current? तुम लोग पढ़ के अगर नहीं आओगे तो फिर कैसे कंटिन्यू होगा? हाँ, ऐसे साइलेंट रहने से. This discussion we have done, na?
Yes, sir.
So what is diffusion current?
The current which due to the concentration of holes and electrons it stores.
Due to concentration gradient, the carriers will move to maintain balance. So in that way, the carrier will move from one direction to other direction. So if you observe in this condition, here holes are more, here holes are less. So hole will move in this direction, higher concentration to lower concentration.
Yes.
So the movement of carrier will happen and current I will get. That current is known as diffusion current. So here now observe. In this case, I'll get more P means holes, and here more electrons. In this area, I'll find more number of holes and less number of holes here. I can say like that. This area, more number of holes are present, and in N side, less number of holes are present. Yes or no?
Yes, sir.
Yes, sir.
Yes.
If you neglect these ions, don't consider these ions. Okay. If I see only P type, I'll find majority carrier holes, so more holes are present in P side, and N side I'll find more number of electron and less number of holes. Now if I compare hole to hole, then here more holes, here less holes. So what will happen? The holes try to move from here to here.
Yes, sir.
Now similarly, if I consider electrons, then opposite, more electrons in N side and less electron in P side, because in N side electron are majority, P side electrons are minority. So majority means more, minority means less. So if I consider electrons, the electrons will move from which direction to which direction? N to P or P to N?
N to P.
N to P. So electrons will move from N to P, hole will move from P to N. So at the instant when we join P type and N type material, then due to this concentration gradient, hole will try to move to N side, electrons will move to P side. That means the majority carriers will flow from one type to other type or one direction to other direction. Right? These are the majority carrier. Here also majority carrier. So majority carrier is moving from here to here, majority carrier is moving from here to here. Now when they move, what will happen? The electron and hole will move together. So you observe this region. You observe this region only and observe the previous. What difference you observe and tell me from here to here?
So there are
One and holes are present there. Only ions are there.
Yeah. So hole will try to move this direction, electron will try to move this direction. So in that process, electron and hole will neutralize itself. Okay, one electron will combine with one hole, so they get neutralized. So here also this hole and this electron will neutralize, this hole, this electron will neutralize, this hole, this electron will neutralize. Like that, all these across the junction or near to the junction, both side, hole electrons will neutralize themselves. But these ions cannot move. They will be wherever the previously before joining, they are also sitting there because they are the atoms which are combined in the crystal structure. So in this region, I'll find only ions or void of mobile charge carriers. Void in other means we say depleted. Depleted of charge carriers. This area is depleted of charge carrier, mobile charge carriers. I'll not find any mobile charge carriers here. And this, due to this region is called as depletion region. Understood? Is it understood?
Yes,
yes,
sir.
sir.
So near to the junction, initially the diffusion process happened. Due to this diffusion process, the near to the junction, whatever the carriers are present, they will neutralize themselves, leaving behind only positive and negative ions across the junction. And this area is depleted of charge carrier. That's why it is called a depletion region. Now, once we know this concept, then let us go more into that. Now you observe only this area. What you observe, only negative ions are there. So net charge is negative here in this region. Similarly, this area will have only positive charge. So I'll have positive net positive charge. So that in this depletion region, I'll get a dipole. Due to this dipole, one electric field will generate whose direction is positive to negative. Whose direction is positive to negative. Understood? Whenever two opposite charges separated by a small distance, then dipole is created. So that dipole is generating one electric field whose direction is positive to negative. So due to this, we are getting one dipole or electric field is generated across the junction. Now, once this happens, further movement of the carriers, that means holes, what are present here, they cannot move this side. Why? Because these positive ions or the net positive charge will repel this positive charge, enter from p side to n side. Opposite charge will attract positive charge or same charge will repel. So hole cannot move to this direction. Similarly, if these electrons try to move n side or p side, that is also restricted because the net negative charge will repel these electrons to enter into this region. So once initially the diffusion process happens and depletion region created, further movement of this majority charge carrier from p side to n side or n side to p side is not possible. And that is due to this electric field generated or dipole generated across the junction. And if I explain that thing in terms of potential, then what I can represent here, this is negative, this is positive. So I can represent like this. Just a minute. This is negative, this is positive. So across this, it is increasing like this, or let me show next. Here you can see this is negative, this is positive. So across the depletion region, it is increasing. Okay, and this is your barrier height. Barrier height means if the holes, these are the holes which try to move this side. Suppose hole is present here and it try to move this side, so it will see a barrier. This is a barrier for this hole. It has to cross this barrier to reach here. Is it understood? Guys, is it understood or not? Or I'll repeat
Yes, sir.
again. This area gives you positive charge, this area gives you negative charge. So if holes will try to move this direction, these will repel these holes, and that can be represented here, this barrier. So whenever this hole try to move from P side to N side, it has to cross this opposition force by this positive ions or positive dipole here, then only it can move here. So this is your potential barrier or the barrier height. I can say this is your barrier height. Similarly, electrons also cannot move this side. So here what is the representation or diagram shown that represents everything? You can see here, this is p-type n-type material. Once the depletion region form, then you can see there is no carriers available in this region, and due to that positive and negative dipole created. This is your positive, this is your negative, right? So electric field is generated or directed from positive to negative. Due to that, the barrier is formed. So if hole is try to move, it has to overcome this barrier, and this is your barrier height. And due to that, the electron or hole cannot move from one side to other side. This is your donor ion, magnetic carrier shown. And as the carriers will not move further, then what is the net current? If carrier movement stops, then what is the current? Can I find any current if carrier will not move?
No, sir.
Zero current.
Zero.
Current is zero. Okay. Now, whatever I have explained, that is only for majority carrier. What about minority carrier? So minority carrier means P side. What about minority carrier?
Electrons.
Electron. So let me represent electron here. 2 electron I am representing here, and N side hole. Now, can this magnetic carrier not move, or the electric field will stop this magnetic carrier from moving?
No.
Why?
There will be some movement, no, sir, because positive.
There will be movement because you can see here, this is my electron, magnetic
Yes,
carrier in P side, and here I am finding positive ions which
Ions.
are attracting these electrons. Similarly, the magnetic carrier in N side is holes. These are the holes, and these holes will be definitely attracted by these negative charges. So movement of these magnetic carrier can be possible, but majority carrier cannot move. So due to this, I'll find some magnetic carrier movement, but the number of magnetic carriers are very small. So that's why the net current is almost zero. Initially, the diffusion process will start. So diffusion means the hole is moving this side. So current is this direction, electron is moving this direction, so current is moving opposite direction, so net current is this IE plus IH. Now if you consider minority carrier, minority means holes are moving this direction, so current is this direction, these are minority, and electron is moving this direction means current is moving this direction. So net movement or minority carrier movement okay, but this diffusion is for very small time, and we can say that net current is opposite to each other, and I can say the net current is 0 when we have not biased the diode. Okay, so finally the conclusion is that whenever we join the p-type and n-type material, depletion region is formed. Due to this depletion region, electric field is generated, and that electric field is directed from n side to p side across the depletion region, and across that depletion the potential barrier or potential I can say built in potential. Okay, this is also known as built-in potential. Built-in potential form or barrier height forms, which further seizes the movement of majority carrier. But minority carrier can move, so net current across the diode is 0. Clear?
Yes, sir.
So these points are written here. When p-type and n-type are joined due to diffusion, carrier movement starts. Electron move from n side to p side, leaving behind positive ions, and holes move from p side to n side, leaving behind negative ions. The region across the junction where only ions are found called depletion region due to the depleted charge carriers in the region. Due to this, dipole is created and directed electric field from n side to p side, and built-in potential or contact potential is developed. Further movement of carrier stops by the developed electric field and contact potential in the depletion region. So at equilibrium, the net current across the junction is 0. Clear to all?
Yes, sir.
Yes, sir.
Okay. Now I'll move to forward bias the junction. Forward bias means I'll connect higher potential across here and here negative potential. This is positive. Let us take compared to positive, this is negative. So plus, minus, I am writing. So in this case, what will happen? This positive potential will repel the holes towards the right side. Yes or no?
Yes, sir.
So when holes are repelled back, then holes try to move this direction. Yes or no? As I increase the potential, then holes will move to right side. So when they will move right side, you tell me if one ion is present and one hole is moving this direction, then what will happen after combination? Negative ion is there and hole is moving towards it, and the hole is reaches the ion, then what will happen? Neutralization happen. That means once it will combine, then this atom negative ion will neutralize or it will become neutral. So if I am giving positive potential and holes try to move to depletion region area, then it will neutralize these ions. Okay. Similarly, this negative potential will repel the electrons. So electron is moving towards the depletion region. So they will neutralize these positive ions. Yes or no?
Yes, sir.
Now, what will happen? You see, now I am having the depletion region restricted to this area only. So compared to the previous condition where the depletion region is from here to here, Now the depletion region is decreases,
Yes.
increases,
Decreases, sir.
decreases. Now
String
depletion
barrier.
region decreases means the barrier potential will decrease or increase?
Decrease.
Decrease. So let us see that one. You see, compared to the previous case, the depletion region here less or not? I have shown two layer
Yes,
there.
sir.
In the no bias condition, two layer is there,
Yes, sir.
and here I have shown one layer. So this is a comparative view, you can understand. And this electric field also decrease because dipole charge is decreases, strength is decreases means electric field will decrease. Electric field decreases means the potential barrier or the opposition force which are restricting this majority carrier to move one side to other side, that will also decrease. So you see, this is the dotted line shows the initial barrier height. Now the new barrier or reduced barrier height is from here to here. So this is your new barrier height or reduced barrier height due to the applied bias. Understood?
Yes, sir.
Now, if I increase the voltage further increase the voltage will reduce this barrier also.
Yes, sir.
All will be ionized.
Sorry,
Now,
sir. Sorry, sir.
if we increase the voltage, suppose
Yes,
I have earlier connected 2 volt, now I will increase to 5 volt.
Yes,
Then
sir.
more positive potential and negative potential I am giving,
Yes, sir.
more holes will move to the junction.
Yes,
And what
sir.
will happen? All these ions will neutralize.
Yes, sir.
I
Yes,
will
sir.
not find any depletion region in that region or across the junction.
Hmm.
So this is the difference. I'll get here majority as holes, majority as minority as holes here, and minority as electrons here, more number of electrons here. So these holes can now easily move from here to here, and electrons can easily move from here to here. So net current will flow. So what is the net current direction?
Direction of P to N.
P to N. So this is P to N. So I can say this is I majority. That is I due to hole plus I due to electron. So this is your I majority directed from P to N. What is written here? Clear?
Yes, sir.
Now, what about minority carrier? Just now I have explained whatever minority carriers are there, they can also during the process of this depletion region, because one by one I am explaining, but these things are happening simultaneously. That means the barrier formation, barrier when I increase the voltage, then the barrier reduction, and at that same time the carriers are also moving. So everything is happening simultaneously. So due to the process of reducing this depletion region, also the minority carriers are present which are moving. So this minority carrier direction is opposite to majority current, because whenever the minority carrier like holes are present in this junction, it will move to this direction, and electrons are present here, they will move to opposite direction. So net current or direction is opposite to the P to N. So this is due to the minority charge carrier. So as a whole, the majority current and minority current are opposite to each other, and we can say the total current across the diode is I majority minus I minority. If you observe majority current in milliampere range and this minority current in microampere or picoampere or nanoampere range. Now what is the ratio? Milli means 10 to the minus 3, micro means 10 to the minus 6, pico means 10 to the minus 12, or nano means 10 to the power minus 9. Yes or no?
Yes, sir.
Now see, 1000 time or 10 to the power 6 time or 10 to the 9 time less. So you can imagine how much less number of carriers are present as minority carrier. But we can consider those things as magnetic carrier. Okay, so whenever the diode is forward biased, I'll get magnetic carrier from P to N side and the net current direction also P to N side. To indicate magnetic carrier is more and the magnetic carrier is less, you see I have taken here the length of this arrow. This length of this arrow is longer and this magnetic carrier length is less. That indicates one is more, one is less. And how much? You can see 10 to minus 3 milli, and my minority, or in next few minutes I'll say is the leakage current, which are there in nano or pico or microampere. Why it is called as leakage current? Leakage means what? Unwanted current. Suppose I'll take a tap, I'll take a bucket and open the tap to fill this tap, and some hole is there in the bucket. So this is your leakage, we say. Yes or no?
Yes, sir.
This is your tap and some water is flowing here. I'll take a bucket and in this bucket one hole is there. So this is your leakage. This is your water which you want to fill this bucket. So the required amount of water is here and leakage is here, both in opposite direction. It try to fill this bucket, it try to empty this bucket. So here also same concept. Majority is actually the current which is wanted from P to N side direction, which is flowing, and minority current is the opposite way, that means N to P side,
Leakage.
which is leakage. Whenever we switch on, then some leakage current will flow. That is very less. If leakage will happen, then you know what type of problems are happening. Suppose I'll take any electronics component and when you power off, still the current will flow across the circuit. That means what? Without our knowledge, the power is consuming by the device. That means the battery will consume more power, or the battery will drain out faster. Yes or no?
Yes, sir.
So that means the leakage current is the unwanted current. We always try to stop the leakage current if we want to increase the battery strength, or if we want to increase the lifetime of our device. Every time we don't want to recharge it or connect to any charger whenever we work or do. So whenever we purchase laptop or mobile or whatever the electronic gadget, we want how much backup it is giving. That means indirectly we try to ask the leakage capability. If leakage is less, then that is good. Okay, so we'll come in detail all those things. So this is all what we have discussed: no bias and forward bias condition. Then we'll move to reverse bias condition. So reverse bias means whatever we have discussed, everything is written here. If the diode is P type, P side is connected to higher potential, N side is connected to lower potential, then diode is forward biased. In the forward bias condition, negative potential force the electron to move and combine with positive ion, and positive potential force to combine with negative ions. In response to that, depletion region decreases, so as the contact potential. As we increase the applied voltage across the diode, the magnetic carrier starts flowing and current across the junction. The minimum voltage from which the current starts increasing is called diode threshold voltage or knee voltage. So this point I have not told. What is this point? This last point, the minimum voltage from which the current starts increasing in the diode. That means we have just now seen, if this is the diode and this is the depletion region, right? When you apply voltage, suppose initially I have started with 0 volt, then 0.1, 0.2, 0.3, like that. I increase the voltage, and this depletion region earlier this, then as I increase the voltage more and more, then this depletion region will decrease. So after certain time, at certain voltage, all the depletion region will remove. Yes or no? there will be no positive or negative ion present across the junction, because this positive electron and hole will recombine and get neutralized all these electron and holes, and ions are also removed here. So at that condition, the holes can easily move from here to here and electrons can easily move from here to here. Now current will start flowing. So the voltage at which the current starts increasing across the diode, and after that, if I increase more and more voltage, current will increase more and more, because there is no depletion region available there. So the minimum voltage at which the depletion region will erase and current starts increasing, that is called as threshold voltage or knee voltage. For silicon, it is 0.7 volt. That means if you increase 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, after 0.7, the current across the diode will increase for silicon diode. Similarly, if you take germanium diode, then if you increase the voltage, then after 0.3 volt, the current will start increasing. In the lab also, you will verify all these things. Have you done this lab? Third experiment?
Yes, sir.
Yes, sir.
So that
Sir,
is,
we have to remember this value, that
this is the default value you can remember. For silicon 0.7 volt, for germanium it is 0.3 volt. Okay, and definition is the minimum voltage at which the current starts increasing is called threshold voltage, knee voltage, cut-in voltage. Different book have a different name, so everything you should remember: threshold voltage, knee voltage, cut-in voltage, minimum voltage, turn-on voltage. Right, different names are there. So all conclude to the same point. Now when we reverse bias the diode, that means P side is connected to lower potential, N side is connected to higher potential. So what will happen here? Just opposite of
region.
increase the depletion region, because whatever holes are present, they will be attracted towards this terminal, negative terminal, and here also the electrons which are present, they will be attracted toward the applied potential. So if this hole will move here, the hole is minority here. Let us take a majority carrier. You know, whenever we have studied the impurity ionization or donor and acceptor adding condition, what we have discussed, if one positive ion is generated, then one electron or one hole will generate. When you add donor atoms, what will generate? Electron or hole?
Sir, holes,
Electron with
electrons with
negative ion
holes,
with hole. Okay. Now you see here, once this hole will taken out, that means what? This hole is taken out, so I'll leave behind only negative ion. Similarly, if this electron will taken out, then I'll leave behind one positive ion. So that is actually happening. So this is combined with one positive ion, this is combined with negative ion. This negative potential will take out this electron. That means, P side, na? So hole will taken out by this applied negative potential. So this hole is taken out means it will leave behind one negative ion which is added here. Similarly, if this electron is taken out, I'll get one positive ion here. So due to this region, the depletion region will increase here. Okay, if you compare the first case, no bias condition, I have shown here two layer of ion. Now for bias, the depletion region is decreases means it shows one layer of ion. Now in the reverse bias condition, as the ions are increasing, that's why it has shown three layer of ion. So depletion region ultimately increases. If depletion region increases, the potential barrier will also increase. Now, is it possible to move this majority carrier, or that means holes to P side to N side and electrons from N side to P side?
No, sir.
No, because no bias. In the no bias, they are not moving. Where two layer of here, where two layer of ions are present, the majority carrier stops moving. Now here three layer of ions are there, then definitely the majority carrier will not flow. So you can see majority is 0. But what about minority carrier? They can easily move because minority carrier means what? Inside holes are minority carrier. So these holes can easily move to this side. Similarly, the electrons present in the p side, these are the electrons, they can move easily to the inside because they can attracted by this positive ion and negative ions. So minority carrier can flow across the junction in the reverse bias condition, but majority current will not flow. Is this idea clear to all?
Yes.
Yes, sir.
Now what is the total current?
Minority current.
I majority minus I minority you have seen, because this is direction is from P to N. Here majority current is 0, so I is equals to I
Minority.
I minority.
This negative direction or negative symbol is due
And
to
P.
yes, P and this current is flowing in this direction. This is also represented by IS. Okay,
Yes, sir.
and this is also called as leakage current. This is also called as leakage current. So what is the points I have explained? Everything is written here. This IS is called as leakage current. Okay.
Yes, sir.
Now look at the IV characteristics.
Sir.
Yes,
Sir, 6, sir.
time हो गया?
Yes, sir.
Yes, sir. हो गया.
Okay. Okay, we'll discuss IV characteristics and current equation next class.
Yes, sir.
So
Yes, sir.
So attendance?
हाँ अटेंडेंस लेंगे ना अभी. Wait, I'll take the attendance. Stop presenting. 87 students are present. Just a minute. Your attendance is not updated in the SAP portal, I think. Is it updated?
No, sir. No, sir.
Okay. So I have taken all the recordings. So whenever it will update, I'll post there.
Okay, sir.
Okay, sir.
Don't leave, just wait. I'll tell. Maybe tomorrow we'll take the test. Okay. Tomorrow is the class. What is the timing of the tomorrow's class?
Till now, no, sir. Till today. We will take tomorrow.